Okay. And I will. Yeah, it feels kind of weird responding to the email, so I'm just going to email Sister Cook directly.
Yeah,
If you want to do the same and just kind of explain the situation, I think she's
totally.
not going to have any problem helping Jessica find a group, you know?
Yeah, yeah, totally. I don't mind doing that at all.
Right.
So when it says what is the value of the test statistic, what is it asking for?
So there's two different ways that we use the T score.
Okay.
One of them is, oops, want to make sure that I've got all the right documents up. Dumb Excel. My computer gets so crowded whenever we do these group
Oh,
tests.
it's insane. Yeah.
So there's two different ways that we use the T score, and I've actually gotten to the point that when I'm working on Excel, I will actually label them differently just to keep it straight in my mind. So I'll do T score calculated, and then the T score calculated is when you do the difference. So you go difference divided by the standard deviation divided by the square root of n, and then
Mhm.
that will give us a T score that we can then use to get our p value and compare the p value to alpha.
Yeah.
The other T score, which is the one where you don't have to calculate because you just use the applet defined, is when you're doing a confidence interval. So in that case, it would just be I do T score, confidence interval, and then you just go to the applet, put in the degrees of freedom, and then do the area 95% because that's usually what we're shooting for. Our level of confidence is 95%. And then you use that T score. So it's not calculated, but we still need to find it. And so
Okay.
yeah, those are the two different ones. Is that if we're using a confidence interval, you get the T score from the applet.
Okay. So if it says what is the value, then are we using the calculated or the uncalculated?
So let's see what we're doing with this one to see, yeah, if we need to calculate. So
Like, I
the
think it's
difference, the null hypothesis, alternate hypothesis, and the population standard deviation is not known. N is 9. D bar is 2.2 with a standard deviation of 3.3. So this one, yeah, I'm not seeing anything that would tell us about like you're doing a confidence interval. So
hmm
this is the T score that we would want to calculate, which
Okay.
is usually X bar minus the mu. But
hmm
since with differences, the mu is always zero because that's what the null hypothesis is that mu is equal to zero.
Yeah.
So, you know, the mean minus the mu in this case is going to be mean minus zero, which is just mean. So you just take the differences divided by standard deviation divided by the square root of n. So
Okay.
that's all this one is asking.
Okay. So wait, you just said it, but so T, we already established that the top will be 0 and the bottom is S divided by square root of n. If the standard deviation is unknown, then what do we put for S?
Oh, say that again.
So for the T score,
Hmm.
we established that the top part of the formula will be 0 always, right? And then the bottom part of the formula, wait, right? Or
If the
0
top if
will be
if the
0.
top of the formula is zero and we divide by zero, what are we always going to get?
0.
Yeah, but we're not getting zero T scores.
Yeah, and so, but like the bottom of the t-score formula is s divided by square root of n, right?
Hmm.
Um, so for s, um, if we don't know the standard deviation, then what do we put?
Well, remember how, for simplicity's sake, we decided to split up the variables? So we have mu versus mean. So the mu
Mhm.
is the population mean, and then the mean is just our sample mean. And same
Yeah.
thing, standard deviation. Do you remember what the population standard deviation is?
Um,
It does start
wait.
with an S.
Oh, sigma.
Yeah. So yeah, when we
Okay.
don't know sigma, then we use S or the standard deviation. And the
Mm-hmm.
standard deviation, if you remember, we can calculate. It's a really hard calculation, so we use Excel, but we can calculate it. And
Oh,
then
okay.
the only difference between sigma and standard deviation
Mm-hmm.
is if we're using standard deviation, we need to specify in the applet what our degrees of freedom are. Because the degrees of freedom, remember, degrees of freedom will change the shape of the curve depending on how big our population is.
Yeah.
So when we don't have sigma, we need to specify how big our sample group is, and that's just n minus one.
Okay.
So
Ugh.
yeah, if we're not given sigma, in this case they actually gave us the standard deviation. But if we're not given sigma, we can calculate the standard deviation. We just have to make sure to include how big our sample size is in the applet, and then we can get the t-score from that.
Okay. Um.
And if we're calculating the t-score, like you're talking about, uh, t-score, if you remember, they're actually like they're so similar that I can kind of see why you're just mistaking them for the same thing. But it's
Mm-hmm.
actually, if we're calculating the z score is x bar minus mu divided by sigma divided by the square root of n. When we
Mm-hmm.
replace sigma with standard deviation, it's the t score.
Okay.
So calculating the t score is just as easy. We just replace it with the standard deviation as opposed to sigma. But yeah, it's not like we're using the same equation for two different things. Like we are using different variables, whether it's the t score or the z score.
Okay.
So does that answer your question?
Yeah. Um. I guess it's just like putting all our lessons kind of together is like, yeah, that's kind of what that was.
Okay.
Okay. So we would use the what is this called? The SD, which is like the sample standard deviation of the difference. So we would use that in place of sigma
Yes.
in the formula. Okay. Okay, so I got 1.1.
I got something different. Maybe double check. The test statistic. Mu is equal to 0. So it is 2.2 divided by 3.3 divided by the square root of 9. So 3. I got 2.
Okay, so you did 2.2 divided by 3.3 over um okay.
Because, yeah, I remember how we'd go mean minus mu. In this case, mu is 0. So it's just mean, which is the d bar, 2.2.
Mm-hmm.
So it's 2.2 divided by the standard deviation, 3.3, divided by the square root of n, and n in this case is 9, so divided by 3. What did your equation look like?
So I just did 3.3 divided by the square root of 9.
Okay. And I'm trying to think. I can see where you got confused. If you did that and times that by the t-score, that gets you your margin of error. So that's just one of those tricky things that you have to watch out for, what you're specifically looking for. In this case, we're looking for the t-score. So
Mm-hmm.
you just got to have that equation either in your notes and just readily available or just instilled in your head. But yeah,
Mm-hmm.
that equation is going to be the mean minus the mu. Mu
Mm-hmm.
here is 0. So just the mean divided by the standard deviation divided by the square root of n.
Okay. Okay, I get it. That makes sense. Okay, sorry.
Oh, no problem.
I got 2.
Okay. Yeah, no, with math heavy classes like this, there's so many steps. You just got to make sure that you go through them
Yeah.
step by step and make sure you're not forgetting anything.
Yeah, it gets kind of crazy sometimes. Okay. So 2.
Hey. Honestly, this is a weird question. I'm not entirely sure even what it's asking. What's your take on it?
So I assume we use the let's see. Do we do it do we use the applet for this one? Probability of obtaining anticipated then.
Well, it's asking for the p-value. And let's see. Let's give it us a percentage as opposed to a t-score. So I want to say, okay, so the probability of obtaining a test statistic greater than Jordan's test statistic. So the probability of obtaining a t-score greater than Jordan's t-score is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. And his hypothesis, hold on, should we be looking at one of the files or no, not yet. So it's just what they've given us. Okay.
So if that's a t-score, don't we just put that into the applet and then we'll get the p-value, which will be the area? Oh wait.
Well, the probability of obtaining a t-score greater than Jordan's is 0.04. So we're given a probability.
Hmm.
Null hypothesis. Let's look at, okay, so if we look at greater than with degrees of freedom of 8, that actually gives us a t-score of 2, which is what we calculated. So I guess the p value is just what they said for 0.403. They just had a really weird worded question.
So the answer is in the question.
That's what it looks like, because if you go to the applet and you put in degrees of freedom 8 and put in an area greater than, so you're just looking at the right side, area of 0.0403 in the right tail, you get a t-score of 2. And that actually makes sense because that's basically verbalizing, the question is verbalizing what I just said. So I guess it is just a question of interpretation. Do you know how to interpret the math and explain it in plain English?
Um, so when I put it into the applet and I put 8 for the degrees of freedom, the area I get is 0.5155.
With 8
Yeah.
degrees of freedom and a t-score of 2?
Oh, no, with a t-score of point. Oh, okay.
Yeah, we got 2 exactly for the t-score.
Okay. Yeah, then that would be. Okay, yeah.
Okay, yeah, I think that was just rephrasing basically the rules of statistics, and it was just like, can you interpret this?
Can you interpret this? Yeah.
Because when you say it, that actually makes sense. The probability of obtaining a t-score greater than his t-score is 0.043. The problem is throwing in t-score or test statistics kind of throws things off.
Mhm.
Think about it this way. The probability, so let's say rather, okay, let's just say this was another question, a normal question. The probability of finding someone taller than our t score is 0.403. Do you see how that is our p value?
Yeah.
It's saying yeah, of the probability of our mean being this high is being higher is going to be 0.043, and that just ring bells of, oh, that's the p value, and p value is less than alpha. We're going to reject the null hypothesis.
Okay.
Just the fact that we're looking for p values based on t scores just put an extra layer on that and got confusing. Okay,
Okay. That
for
makes
this
sense.
one we do need the Excel sheet.
Okay. So let's see.
Okay, make sure it's specifying, make sure that you do group 1 minus group 2. Otherwise, you'll get the right answer, but it'll be the wrong sign.
Oh, okay. Group 1 minus group 2.
Yeah.
Dang, how did I do it on the other one?
Okay. So I got the next two questions. You having trouble on any of the equations?
Uh, um, ish. I did this earlier in the homework where I typed in the differences in that column. Um,
So what part are you stuck at?
so I know you do equal to, and then you click on A5 minus A or B5, and then you press enter. And then how do I bring that formula down?
Oh,
Oh, it's the black one, I think. The black little. There, got it. Got
okay. You're able
it.
to drag it down
Sorry,
so
it's
you
like
didn't have to
I
do
totally
all
did
of them.
this earlier. What did I do? Okay. Let's see.
Yeah, I kind of feel as though during the first week when we weren't doing stats and just doing like the Google activity and that kind of stuff, I think there should have been kind of an orientation on Excel.
Oh, totally. Okay. Okay. Sorry, I'm typing in all these equations again. So for standard deviation, do we do the standard deviation point S?
Yeah, so stdev.s, then parentheses and put in your cells.
That's what I thought. Okay. Okay. Now that I have all that set up, so what is the test statistic? Okay, so it's gonna be. So is it gonna be 0.407?
That's what I got.
Okay. Sorry, I'm so slow.
No, you're good. Okay, so what's the next step now that we have the t-score?
The p-value. Um,
But just go to the applet, put in our degrees of freedom and the t-score, we can get the p-value.
so 0.6887.
I got 0.689. That's just rounding.
Oh yeah. Okay.
So the interpretation of the data, we reject or fail to reject.
So we would. Okay, so the p-value. So we would fail to reject the null.
Yes. Okay. So next question, suppose your alternative hypothesis instead of mu difference equal to zero, alternative hypothesis, mu difference not equal to zero is instead mu difference is greater than zero. First off, what would that change about what we just did? What would we have to alter in order to correct this to make sure that we're answering the right question?
So we would have to change the type of test it would be to greater than.
And what does that entail?
That entails looking at the right-hand side of the applet.
Yeah, perfect. So basically we just unhighlight the left-hand side and then
Yes.
look at our new p-value.
Okay. And then, so the p-value is smaller now.
But is it small enough? That's the question.
So it is still larger than our alpha. So we would still fail to reject the null hypothesis.
Okay, you are completely right. That's not how the answers are phrased, though.
Okay, so
So look over the answers and see which one's correct.
okay. So we have sufficient evidence that the mean of the differences is greater than 0.
Are we rejecting or failing to reject the null hypothesis?
Failing to reject. So we have insufficient evidence that the mean of the differences is greater than 0.
Yes, perfect.
Okay.
Looks like the next few questions is the next data sheet, data B1. To do the same thing of calculating the difference, then get the average of those differences. And group 1 minus group 2.
So our confidence level would be 0.99, correct?
Yes.
So for number 9, n would be greater.
And y.
So n is 22, and what is df?
Degrees of freedom.
Oh,
Do you
I
remember what the remember what the definition of degrees of freedom is?
um the exact definition. Oh, it's the sample minus the minus 1.
Exactly. So by definition, n will always be bigger.
Okay. Well, that was an easy question. P-value. Did you get 0.0035? So I guess 0.004.
That's something else.
Oh, you got something else?
What was your T-score? Your answer actually makes more sense than mine.
My T-score is 3.288.
288. I got 3.7 for some reason. Let me double check this.
Oh, do we round to one decimal place?
It says round to 3 decimal places.
Okay.
At least on question 10 it does. What'd you get for your average of the differences?
Let's see. So for I got 10.4.
Or I got 11.95. Did I?
Maybe I did something. Wait, oh, I think I did do something. It's my fault. I did not change this part. Okay. Sorry,
Okay.
that's my fault.
Oh, no problem. Just let me know when you get your new T-score and what you got for that.
I always forget to change that. 1 second. Okay. Okay, so for my let's see, my new p-value is 0.001.
Hmm.
You didn't get that?
What did you get? Okay, so I got the degrees of freedom there. What was your new
T
uh, T-score? Yeah,
3.7.
3.7.
Mm-hmm.
Try not rounding it off.
Okay. For my p-value or
For the T-score.
so 3.737.
Okay. Now try putting that into the applet.
Okay. Okay, so I got 6.081 to the -4.
Huh. Okay, no, that makes more sense. Um, I'm just
Maybe I'm
my
doing something wrong.
no, that actually makes sense because I've just been getting 0, and I don't know
Oh,
why mine isn't displaying in scientific notation. So that just means that for some reason yours is being more accurate, which is weird for me. But that makes sense because I had my p-value as 0, which doesn't feel right.
yeah.
Whereas you said rounding, that would make it 0.001 since you said it was 0.0006, right?
Um, yes.
Okay. Then with rounding, yeah, that brings it up to 0.001, which is an actual answer, as
Hmm.
opposed to just putting 0 there.
Yeah. Okay, so it would be 0.006
So you
if
said
it's
scientific, it was 6
so
e 10
6
to the negative fourth.
so 6.0816 e-4. So
Okay, so e minus 4. So that means you're counting off from the decimal point, and the negative number tells you where your number starts. So -4 would be decimal point 0.0006,
6.
but we round to the third decimal point, so that would just be 0.001.
1. Okay, yep, that makes sense. Okay. Okay, I lost my quiz. Too many tabs up. Where did it go? Okay, here we go. Okay, so our p-value is 0.001.
Yes.
And what decision do you make? So if it's So it's smaller than alpha.
So if P is smaller than alpha, what do we do?
Reject the null.
Yes.
Sorry, to do that in my brain, I don't know why it takes me so long to think about that, but
No problem. You're getting it right every time, so.
but yeah, just I don't know why it just takes me like a hot minute to
Oh, no problem. That was. I'm
um,
not dyslexic. I'm just stupid. And like, 'cause back in high school when I was playing football,
uh-huh,
I would always get my lefts and rights mixed up. Like if you
uh-huh,
were to ask me, I'd be like, "Oh,
right.
the right side of the room," and I'd be right. But for some reason, like when it came to my body, it was just weird. And so my coach, he'd be like, "Get started on your right foot, Nielsen," and like I'd almost always, start on my left foot because I was playing on the line. And it was just so bad to the point that he literally he's like, "Oh, give me a marker," and he got a marker and he made me write R and L on my cleats. Because I would always just take that extra second to figure out, okay, which one's my left, which one's my right,
Uh-huh.
and that's all it would take to get plowed by someone. So he's
Yeah.
like, okay, he's like, you don't have to learn it. Just look down at your feet and you know which way to go. Okay.
Oh, you gotta love coaches and their way of
Yes.
teaching. So great.
So yes, do not feel bad if it takes you a second to let those gears run a
I
little
know, I'm
bit.
like, yeah, it's working slowly but surely.
Okay,
Oh
so we
man.
decide to try another alternative hypothesis. Instead of mu difference is not equal to zero, you do mu difference is greater than zero and keep the same level of significance. When we go from a two-tailed hypothesis to a one-tailed hypothesis, what happens to our p-value?
It goes down. It
Yes.
decreases.
Yeah.
Oh,
We're unhighlighting one half of the area that we're looking at, so our p-value is just going to go down.
huh. Easy peasy.
And then with the smaller p-value, what do we do?
We still reject the null.
Yes, because it's just going down. So we would always, if our p-value is smaller than the alpha, and we reject the null hypothesis. If our p-value goes down, then we're just going to reject it again.
Okay, makes sense. Easy enough.
The previous questions, what conclusion do you make?
We have sufficient evidence that there is a mean difference between the two groups.
Yes. 40, so I just want to make sure and double check all the
Yeah,
answers.
no, you're good.
Sufficient evidence that there is no mean difference. No, we don't have evidence of that. And then answers 2 and 4, we do have sufficient evidence because our p-value is lower. So we have sufficient evidence that there is a mean difference. So yes.
Okay.
I hate wordy questions like that. You just have to
Yeah,
like go through and comb through everything.
trips you up sometimes, yeah. Okay.
As we have seen, p-value depends on the alternative hypothesis. Which type of alternative hypothesis gives the smallest p-value?
I feel like it less than?
Why do you say that?
Well, I was thinking, like my thought process was like, okay, it's definitely not the not equal to because you're highlighting two sections. And then the greater than less than you're only hmm,
What do we know? What do we know about the curve that we're looking at? What kind of distribution is it?
normal?
Which means that it's symmetrical, right?
Yes.
Which means that the less than should be equal to the
Two.
greater than.
But usually the left-hand side would be negative, right? Oh, but if it's the p-value, then that doesn't even matter. Okay,
Exactly. Yeah.
so not enough information depends on the problem.
Exactly.
Okay.
Yeah, frankly, I just think that's kind of a poorly worded question, but you understand the concepts perfectly there.
Yeah.
That we're always going to have a greater p-value if we have a two-tailed hypothesis as opposed to a one-tailed hypothesis.
Yeah. Okay.
Okay, so we're going back to the sheet. And this time we're doing a 95% confidence interval. So that means rather than calculating the t-score, we're going to do a t-score based off of 95%.
Okay.
We go to the app. Our degrees of freedom 21. Highlight that middle area. 95. And let me know when you have the t-score.
Okay, so am I still using the same information we've been using?
I haven't seen any difference, so I'm assuming that we're still using the Chapter 12 Data B Excel sheet.
Okay. Okay, so I just put, oh wait, I can do it the other way actually. Okay, help me out. So wait, the mean difference between the two groups. So which section would I highlight?
So what's the null hypothesis?
Okay, so the null hypothesis is, um, okay, so, equal to 0.
Wait, say that again?
Equal to 0?
Oh, you're totally
Maybe?
right. I asked the wrong
Oh, okay.
question. So that's the null hypothesis is that it's equal to 0. What's the alternative hypothesis?
Not equal to 0. Oh, okay, so we would do the two sides. Okay.
Exactly.
And I put in the area, correct?
Yeah.
Point 95.
And 5, yep.
Okay. And then I got my t-score negative or 0.063. Okay, what is the question asking for? Okay, so would it be 0.063?
Which area of the graph do you have highlighted?
The two sides.
Okay, so if you highlight the two sides and then put in the area, what happens?
Um, pretty much the whole thing is highlighted. Oh, wait. Do you have your degrees of freedom as 21?
Yes.
Okay. Yeah. And then my t-score shows up as 0.063.
Okay. And so basically everything is highlighted except for the very middle section.
Yeah.
Okay. So you had a little dyslexic moment there, which is
Did I?
fine.
Dang it.
When we're doing the confidence interval, if you
Uh-huh.
remember, confidence interval, we are looking for the data that falls within 95% of the curve. So we actually highlight the middle. Another way you could do it is highlight the ends like you did, and then
Uh-huh.
put your area in as 0.05.
I did that last time too. Okay, I need to actually write this down because I always do that. Okay, so if I want to do um, either the area to be 95 I would need to highlight just the middle. Or, so the other way to do it would be to do, for the area, hold up, sorry. So the other way to do it could be, you could do the area as 1.96 and then highlight both both of the side. How does that work?
What area would you do?
Would you do the area as the 1.96?
Where are you getting 1.96?
That's the z-score for 95%.
But remember, we were dealing with the students' T probabilities, and so those T score, those are for Z scores, and we're dealing with T
Oh.
score.
Okay. Okay, so the other way to do it would put the t-score would be 1.96.
Say that again.
Um, so there's two ways to do it, right? So you could either put in the area 0.95, or you could put the t-score in as 1.96, or whatever the thing is for that, right?
Not necessarily,
Oh.
because we're trying to find the T score. Well, the Z, yeah, we're trying to find the T score here. So the
Oh, sorry,
very,
say that again.
so we're trying to find the T score here. We don't have a T score to put into the app.
Okay.
So we have to put in a degrees of freedom and an area, and then get a T
Mhm.
score from that.
Okay.
And then the two ways that we do it is just two sides of the coin. Either we select the middle, which is going to be the bulk of our data, and we look
Uh-huh.
for what lies within 90, we look for 95% of the data within the curve. So we select the middle of the curve and type
Uh,
0.95, and that will give us the T-score that encompasses 95% of the data. The other way to
uh,
do it is you highlight the ends and then
mhm.
type in 0.05, and that will give you 5% of the outliers, which
Uh,
is just the inverse of finding the 95% of the bulk. Either way, you'll get the same T score. It's just two different ways to do the same thing.
okay.
You just have to make sure that you highlight the right area
Hmm.
when you type in your area.
Okay. Yeah, that makes sense. Don't know what I was thinking.
I
Okay,
don't know.
so for my T-scores, I got 2.08.
Perfect. That's what I got.
Okay.
And the first question doesn't even care about that.
Ah.
So it's asking about the point estimate. Do you remember what the point estimate is conceptually?
Um, yes. So there is point estimate, or there is an interval estimate.
Mm-hmm. And
The
we need both
point,
of them to make our confidence interval. And
yeah.
so
So pretty much the point estimate is our mu.
you're super close.
Um, it is mm,
What's mu?
mu is our um population sample.
Wait, say that again.
Is our population mean, I mean.
Okay. And so the population mean. So what's the other mean that we deal with?
Sample mean.
Yes. And what's that variable called?
Um X with a bar.
Hmm. And in this case, they've been specifying because it's difference, they've been calling it D bar.
Hmm.
So, but yeah, that's what we're looking for is the mean, not the mean of the population, but the mean of our sample. So D bar is going to be the point estimate.
Oh, okay.
So the average of all the differences that you got.
Oh. Oh, okay. So, um, did you get 11.954?
Yes, perfect. Actually, should be 11.955 because I
Yeah,
got 0.94, I mean 0.95455.
rounding. Yeah. Okay. Okay, and the margin of error. Oh, what?
So do you remember what the equation for margin of error is?
Yeah, so it's gonna be sorry, it's gonna be sigma times z-score over square root of n.
Which is normally what it is. We are dealing with, and this is
T-score.
being really nitpicky, yes. But this is being,
So
so since we're dealing with t-scores, what are the variables we're dealing with?
so it would be sigma times t over square root of hmm,
You are super close.
okay, so it'd be t-score times standard deviation over square root of n.
Perfect.
Okay.
Yeah, you're saying sigma before, which is the population standard deviation, which we don't have. And I realize that's a super little nitpick, but like I said, like
Yeah.
that's specifically why I'm trying to change the vocabulary so we don't get those things confused.
Yeah, exactly. Okay, so it will be What did you get?
I got 5.301.
Okay. What the heck am I doing? So our T-score is... What T-score did you use?
What T-score are you using?
I don't know why, but I put in 3.737.
Okay, that's the problem.
Okay, so
It,
um it should be 1.96 though, right?
no, it's
Okay.
super close though. When would it be 1.96?
Okay, so that would be when it's not calculated.
And it's not calculated here because we know that we're doing a 95% confidence interval. So when would a 95% confidence interval always have a T-score? Well, actually, let me rephrase this. Um, that's actually hard to phrase. Okay, so a 95%. Yeah,
Oh.
she's just been she's been circling. She's been circling the computer, and she's like obviously wants attention, but she's been staying out of reach. She's less affectionate than Wednesday, but she
Uh-huh.
can be really needy. Freya, do you feel
Oh.
better? I can feel you purring, even though you're probably going to shriek pretty soon. She's got such a she's I don't I don't want to make her meow, but
Uh-huh.
if you can hear her, Freya. Yeah, did you hear
Oh
that?
my gosh.
She's got such a hoarse, scratchy meow that when
Yeah.
my brother got her,
Uh-huh.
he for like thought for like the first 2 months that she was sick, and so he like brought her into the vet, and the vet's like, "Nope, that's just how she meows. She's just got a very screechy meow." So she's just a screechy
Oh.
kitty. Okay. Anyway, okay, so let me think how to put this. Okay, what is 1.96?
So that is the Z score,
What are we dealing with?
T score.
Yes.
Dang
And the
it.
T score for a
No.
95%
Oh, I
confidence
don't mixed up wanting to make them the same.
well, that's why we gave them different variables. So you got to remember Z score versus T score.
Okay.
And for to find out what the T score is for a 95% confidence interval, what do we need? What's the
Um,
T score dependent on, unlike the Z score?
mm,
Think about the
oh,
applets.
degrees of freedom.
Exactly.
Okay.
So while you're completely right, if we're doing Z scores, it
Mhm.
would always be 1.96. And if you ever forget that number, you can pull up the app and just go uh, 95%, a 0.95, and you'll get that Z score of 2. Um, but here it is dependent on the degrees of freedom. So we have to pull up the app every single time when we're using T score.
Okay. I'm just writing this down. Sorry.
No
Okay.
problem.
So I would use the applet and I would,
The very top, put in your degrees of freedom.
which is 21 still, right?
Mm-hmm.
And then,
Make sure you highlight the correct area of the curve and then put in your 0.95.
okay. So it's 2.08. Okay, so we did get
Yes.
that.
So it's very close, but because we're dealing with a T score and our N isn't quite high enough, like if I bet you if we had an N of 100, so our degrees of freedom was 99, it
Hmm.
probably would be like 2.001 or something. But this is still actually really close. But that difference is still there. So
Uh-huh.
every time you deal with a T score, make sure you can't just use the 1.685, 1.96, and 2.5, whatever. I can't remember what the last one was. Like you can't use those. You actually have to go to the app and find your T score every time.
Okay. Um, Okay, so I would do 2.08 times, I really should put this in Excel, it might be easier. Standard deviation, which is 15.003 divided by square root of n, which is 22.
Mm-hmm.
Okay, I got 6.65.
Little bit off. There may have just been a rounding error. I got 5.3.
You got
Let me double
5.3?
Yeah, let me double check my calculation. So I've got
Probably me. I did something wrong.
we got t-score 2.08
Mhm.
times standard deviation 15.0031, which is oh nope, that one was on me.
Okay.
I had the X bar highlighted in my Excel sheet, so I was using the mean instead of the standard deviation.
Okay.
We go 2.08 and standard deviation, which is 15.003. Divide that by the square root of 21. Okay, you said you got 6 point, what was it?
6.653.
Perfect. Yeah, that's what I got.
Okay.
Okay, so you're totally right on that one. Thanks for catching me.
Okay.
Okay, and the final step is we're trying to find the actual confidence interval. So what do we do with our margin of error in order to find our upper and lower bounds?
We minus it from why did I forget the stuff? Okay, we minus it from
Because it's the same thing, but we're calling it different variables with every new lesson.
yeah,
It used to be X bar, and now because we're dealing with differences, they called it D bar, but they're all just the mean.
okay, so we minus it from the mean. That
Mhm.
totally makes sense conceptually. So, and our mean is something. Is there okay, so our mean is 11.955, right?
Yes. Um, I have it in Excel as 11.95455. And that's
Okay.
what I like about Excel is that
Gives you
it,
more exact.
yeah, it lets you save rounding until the very end. I'm not sure if rounding that to three places would affect our answers, but Sister Cook has kind of stressed that make sure you don't round until the very last step.
Yeah. Okay. Okay, so 5.302.
I got one.
Oh,
I just
you
want to
got
see if that
one?
was a rounding area. Yeah, I got 5.3013. So it was your fourth
Um,
decimal.
so I got 5.3015.
Five. Huh. Not saying you're wrong. I'm
But
just going to go with 301
okay, let's
because
do
I'm
that.
just with Excel. It's just I've got a
Way more
lot
accurate.
of yeah.
Yeah. That no, that's totally. And what is the upper? So 18.608.
And that's what I got. Okay, save, submit quiz. And we missed one.
Dang it, which one was it?
We missed. Okay. What is it? Okay. So it was question 4. That was the one that we didn't understand what it was asking.
Oh.
The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value. That's such a weird question.
Yeah.
Let's see. Let me try. No, I was gonna say let me try and calculate the t-score and see what it is. But yeah, that's the thing, is that with n equals 9, so degrees of freedom is equal to 8, a t-score of 2 gives you that percentage. So, okay. Oh, no, wait, hold on. That's the problem. Okay, try this. Go to question 4.
Okay.
This was the problem. Do you remember how on question 12, you change your hypothesis from a two-tailed test to a one-tailed test,
Yeah.
and the p-value decreases? That's what we were missing.
Okay.
So on question 4 is the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. So right now we've got alternate hypothesis is greater than 0. Whereas in the actual hypothesis, we're looking at mu is not equal to 0. So it's a two-tailed test.
Oh, okay.
So the p-value should be just double that, 806. So try putting in 806 and see if that gets you the right answer.
Mm.
Or actually, have you done that yet?
Working on it. Why, what's up?
Oh, I just pulled up the applet, put in degrees of freedom 8 with a t-score of 2 and highlighted both sides. And rounding, it's giving me 0.0805 instead of 806. So put in 0.0805.
Okay.
Or actually, is that even right? Round to 3 decimal places. 0.0481. My bad.
Point
It's just
zero.
0.81.
Yep, that's right.
Okay. Okay, so at least we understand what that was asking. It was basically just an example of if you change from a two-tailed test to a one-tail or vice versa, your
Yeah.
p-value changes. Okay, then I'm just going to fix that, and that sounds like we're good to go. This all makes sense. Like I said, it's
Yeah.
pretty much last Thursday and last Tuesday, just with different just calling variables different words
Different
now.
things. Yeah, I understand it. It seems pretty straightforward. So,
Okay.
all right.
Um,
So Thursday, you'll be in my time zone. So we'll meet same time my time or same time it would have been for you.
Same time for you, so 6 o'clock, just Thursday
Okay.
6.
Okay.
Um, since I am gonna be with my parents, they've taken everybody places like Gatorland to go wrestle
Hmm.
some gators and stuff.
So
So I'm
fun.
not sure what they have planned,
Okay.
but if it interferes with our Tuesday Thursday thing, I'll let you know as soon as possible so that we
Totally
can
just let me
just
know.
rearrange.
Yeah, we
Okay.
can, I mean, you're on vacation, like enjoy it. So we
Right.
can figure it out if we need to change times. No big deal.
Yeah.
Just let me know.
But yeah, I'll let you know as soon as I know. That way, it's not like 5 o'clock Thursday, and then all of a sudden you get a text from me, and I'm like, "Hey, can we do this yesterday? Because I'm busy all night tonight."
Oh, it's toast cool. You're good. So just let me know. It's fine. No big
Okay,
deal.
I'll keep you in the loop.
Cool. All right. I'll see you later.
Okay, see you on Thursday.
Bye.